Okay, so for this last area problem, we have the graph of f of x is 1/4 plus sine pi x and 4 to the negative x. So let's go ahead and graph those in our calculator. So we have 1/4 plus sine pi x, and then in y2 we have 4 to the negative x. And then if we change our, well, we don't really know our window, so let's just do zoom 6, it'll be back to normal. So that's way more than we have going on. So let's change it to window 0, let's just do 0 to 10, and 0 to 10, and just see what happens. Okay, so if you want to leave it like this, that's fine. You can see that really the main part of the graph is happening right here. So we just need to find these. I'm going to go ahead and find these intersections because I know I'm going to need them. So I'm going to do second trace intersect, and I'm going to move it to the first one. Okay, so on your graph here, if we label this first intersection here, I'm going to label it down here, is at 0.178. And if you look at the first question, actually here it says identify the points of intersection, so we're going to need to write the x and y values. Let's go ahead and jot those down. So we're going to have 0.178, and the y value that goes with that is that 0.781. Okay, so then if we do second trace intersect for the next point, and I'm going to move it to the next one. This happens at 1, and if we write that point down here, that's at 1 and 0.25. Okay, so we found the points of intersection, and we will need those. So the next thing it says is find the area of R. So region R is this part here. Okay, so if we're doing region R, we know that this starts at 0 is where that's going to start. So if I make my area, it's going to start at 0 and then it ends at this 0.178. Now, the graph that is on top here, this is my 4 to the negative x graph. So that's on top, so we're going to need to make sure that we put that first. And then it's always minus, and then the other graph that we have here is our 1/4 plus sine of pi x. That's on the bottom, so we're going to make sure we subtract that. So when you're doing area, make sure that you have the top, so in this case that's the 4 to the negative x, over the bottom, and you have start at 0 and we go to 0.178. So you would type this into Math 9. I'm going to let you just try that so we don't spend as much time on the video. And make sure you can get 0.065 because its area it would be units squared. Alright, so for the next one we want to find the area of S. So for the area of S starts at 0.178. And the area of S ends here at 1. Okay, so for this one, this time the curve is on top. So this is the 1/4 plus sine of pi x is on top. So we're going to do that first. And then it's always subtraction in the middle for area. And then the curve on the bottom here is the 4 to the negative x. And we always have dx. So you can put this in Math 9 on your calculator and just confirm that you can get 0.410, and this would be units squared. Okay, and then the last part here, we want to find the area of the unshaded region bounded by the graphs of f, g, and the x-axis. So we want to find the area of the unshaded region, so like this part down here. Okay, so if you see here, what we can do is, and you can do this a couple different ways, but I think the easiest way, so this starts at 0, and it goes over technically to here, not to 1. So let's figure out what that value is. So if we go back to our calculator, I'm going to put 0 into y2 instead of 4 to the negative x. And then, so that way we can see where that graph. And then we'll do second trace, intersect. And I want to see where this touches the x-axis first. So it touches the x-axis here at 1.080. Okay, so here's what we can do. If we want to find this area here, we do have to go from 0 to 1.80. So I'm going to draw like a little picture here of what I'm going to actually do. I'm going to find the area under this whole curve. So from 0 to 1.80, I'm going to find this whole area. And to find that area right there, we are going to make an integral from 0 to 1.080. And that just uses this curve of 1/4 plus sine of pi x, and it uses the x-axis. It doesn't actually use the other graph at all. So I can do 1/4 plus sine of pi x. And if I want to do the minus 0 to represent the x-axis, you can, but it's not necessary. Okay, so that's going to be the area of that part. And then what I'm going to do, because I don't need that whole area, I just need the area of this part that is left over, I can just subtract out what S is going to be. And I do already know the area of S. So if I subtract out S, then that'll leave me with what's left over. So I'm going to subtract. And I'm going to make another picture here. So for the other one, I'm going to subtract out S. So I'm going to subtract out this part right here, which is S. And S went from 0.178 to 1. Remember, that went to 1 there. So that integral, which I've actually already found in the last part, was the 0.178 to 1. And that had 1/4 plus sine of pi x on top, minus that had the 4 to the negative x dx. Okay, but really this is just the area of S. So if we subtract out the whole area under the curve minus S, that will leave us with that orange part there. So if you do this in your calculator, use Math 9. So for this part here, you'll get 0.897 minus, we already found the area for S up top, that was 0.410, so you don't have to type that in again. So we're going to end up with 0.487 units squared. So sometimes if they ask you for areas, you may have to find areas and then subtract them to make them into the area that you actually need. Okay, so that is area. Really, it's just area under the curve where you start and stop for your integral. It's the top minus the bottom. Okay. The next thing, just shifting gears a little bit, is arc length. So arc length tells you the length of a curve. So this is just kind of thrown in here. But the formula for arc length, and arc length is represented most of the time by an S. It's also going to be an integral. It's the integral from A to B, so where it starts and stops. The square root of 1 plus the derivative of f of x squared, and then dx. So this is the formula for arc length of a curve. Okay, so for this last problem, all we want to do here is, it says, write the integral that would give the length of the curve of y equals ln x from x equals 1 to x equals 2. So we're not even solving, we're just writing the integral. So when it says give the length of the curve, that means you want to find the arc length. Okay, so a lot of times it's not going to say arc length. That's going to say the length of the curve. So the formula we need to use is from A to B. Well, it tells you it goes from 1 to 2. So from 1 to 2. And then the formula is the square root of 1 plus. Okay, if y is ln x, I know the derivative of ln is the derivative of the inside, so the derivative of x, which is 1, over the inside, which is x. So 1 over x, so this is, the derivative is 1 over x, and then it's squared dx. So we could leave it like that, or they may simplify it. So the integral from 1 to 2, the square root of 1 plus, we could say 1 over x squared dx. And if you wanted to find this using your calculator, you could just use Math 9. But that right there is how you find the arc length. So this is just a formula that you need to know. It goes along with area because we're using the integral, but it's just the arc length of the curve.